It took you 3 years of law school and months of sleepless nights to pass the bar exam. It took a team of medical students a decade of intense study to clear the U.S. medical licensing examination. And for those shadowy figures in the intelligence community, it takes a lifetime of training and psychological vetting to clear the CIA's most rigorous entrance tests. But recently, a cluster of code sitting on a server farm in a remote warehouse passed all of them in a single afternoon. We aren't just talking about a computer being good at math anymore. We are talking about the moment artificial intelligence stopped being a tool and started becoming a professional peer. If a machine can outthink a lawyer, outdiagnose a doctor, and outmaneuver an intelligence officer, we have to stop asking what AI can do and start asking what is left for the rest of us. The bar exam is arguably one of the most stressful experiences a human can go through. It isn't just about memorizing laws, it's about logical reasoning, applying abstract principles to messy real-world scenarios, and identifying the subtle traps in legal language. When GPT-4 was released, researchers decided to put it to the ultimate test. They didn't give it a simplified version. They gave it the uniform bar exam. Not only did it pass, it performed in the 90th percentile. That means this algorithm performed better than 90% of the humans who sat for that same exam. It understood hearsay, property law, and complex torts as well as a senior partner at a top-tier law firm. This wasn't just a win for Silicon Valley. It was an earthquake for the entire legal profession. But the machine didn't stop at the courtroom. It moved into the operating room. The USMLE, or the United States Medical Licensing Examination, is a three-step gauntlet that ensures doctors are safe to practice. It requires deep clinical reasoning and the ability to synthesize vast amounts of biological data. AI models are now clearing these hurdles with ease. They aren't just reciting facts from a textbook. They are looking at patient symptoms, identifying rare conditions, and suggesting treatment plans that align with the latest medical research. In some studies, the AI's bedside manner, or at least its written communication with patients, was rated as more empathetic and thorough than that of human physicians. Think about that for a second. The silicon was more human than the human. Then things got even more interesting. There are rumors and reports of these models being tested against the entrance and analytical requirements of the CIA. Now, we aren't talking about physical field training or jumping out of planes. We are talking about the analysis of competing hypotheses. This is the core cognitive framework used by intelligence officers to prevent bias and predict global events. The AI was able to ingest thousands of disparate data points, from satellite imagery logs to diplomatic cables, and output intelligence reports that were indistinguishable from those written by veteran analysts. It didn't get tired, it didn't have a political bias, and it didn't miss the small detail hidden on page 5,000 of a boring document. To understand why this is happening now and why it didn't happen 10 years ago, we have to look at the architecture of these systems. We have moved from narrow AI to the doorstep of artificial general intelligence, or AGI. Traditional AI was like a calculator. It was brilliant at one thing but useless at everything else. The new era is built on large language models and transformers. These systems don't just know things. They understand the relationships between concepts. They use something called far self-attention mechanisms. This allows the model to look at a whole sentence or a whole legal brief and understand which words are the most important based on the context of the entire document. It mimics the way the human brain focuses on specific details while keeping the big picture in mind. But how does a machine pass a test it wasn't specifically trained for? This is the phenomenon of emergent properties. When you scale these models to a certain size, they start developing skills that the programmers never intentionally wrote into the code. The AI didn't have a law mode or a doctor mode. It simply learned the structure of human knowledge by consuming nearly everything ever written on the internet. By learning the patterns of language, it accidentally learned the patterns of logic, ethics, and specialized expertise. It's like learning to play the piano so well that you suddenly find you can also play the organ and the harpsichord without anyone showing you how. So what is the what's next part of this equation? If the baseline is passing the hardest tests humans can create, the next phase is creation and discovery. We are entering the era of AI scientist and AI inventor. Right now, it takes years and billions of dollars to develop a new drug. An AI can simulate millions of molecular combinations in a fraction of a second. It can predict how a protein will fold, a problem that has baffled biologists for 50 years. One AI model recently discovered a new class of antibiotics that can fight drug-resistant bacteria, something humans haven't been able to do effectively in decades. The AI didn't just pass the medical boards. It started writing the next chapter of medical history. In the world of law, we are moving toward the automated judiciary. While we might not have AI judges tomorrow, we already have AI systems that can predict the outcome of a court case with 80% accuracy just by reading the initial filings. This is going to change how companies settle disputes and how insurance claims are processed. If an AI knows you have a 90% chance of losing in court because it has analyzed every similar case in the last 100 years in 3 seconds, you aren't going to go to trial. The entire concept of the day in court is being replaced by the calculation in the cloud. For the intelligence community, the what's next is even more profound. We are looking at predictive geopolitics. Imagine a system that monitors every news feed, every shipping manifest, every social media post, and every change in weather across the globe. It could predict a coup, a financial collapse, or a supply chain crisis weeks before they happen. It would be like having a crystal ball made of data. However, this creates a new kind of arms race. If every country has an AI that can predict the future, they will start using those predictions to try and change the outcome, leading to a feedback loop of increasingly complex digital maneuvers. Technically, the limits of these models are also being pushed in the realm of context windows. Earlier versions of AI could only remember a few pages of text at a time. New models have context windows that can hold entire libraries. You could feed an AI a 1,000-page technical manual for a fighter jet, and it could instantly tell you how to fix an obscure mechanical failure on page 842. This isn't just Ixby search on steroids. It is comprehensive synthesis. The AI holds all that information in its active memory simultaneously, allowing it to see connections between the first page and the last page that a human would likely forget. What does this mean for the person listening to this right now? It means the definition of skilled labor is changing. For a long time, we thought the blue-collar jobs would be the first to be replaced by robots. We thought the safe jobs were the ones that required a degree and a high IQ. But the reality is exactly the opposite. It turns out that walking, picking up a glass of water, and navigating a busy street are incredibly hard problems for a robot to solve. But passing a bar exam? That's just data and logic. The white-collar world is currently facing a massive disruption because it turns out that being an analyst, a researcher, or a junior lawyer is exactly what AI is best at. We also have to talk about multimodality. The AI that passed these tests was mostly text-based, but the next generation can see, hear, and speak. An AI doctor wouldn't just read your chart. It would look at your X-ray, listen to the rhythm of your heart, and notice the slight yellowing in your eyes through a camera. An AI lawyer wouldn't just write a brief. It would analyze the video footage of a witness and detect the micro-expressions that suggest they are lying. The integration of various senses into a single logical model is going to make these systems exponentially more capable than the versions that cleared the bar exam. But it isn't all sunshine and progress. There are massive technical and ethical hurdles. One of the biggest is hallucination. These models are designed to be helpful, and sometimes they are so helpful that they make things up. There have been cases of lawyers using AI to write court filings, only for the AI to cite legal cases that never actually existed. The machine is so confident in its language that it can sound perfectly logical while being completely wrong. This is the black box problem. Because of how these neural networks work, even the creators don't always know why the AI reached a specific conclusion. For a CIA analyst or a surgeon, a wrong conclusion, no matter how confident it sounds, is a disaster. This brings us to the concept of human in the loop. The what's next isn't necessarily the replacement of humans, but the centaur model. In chess, a centaur is a team of a human and a computer. This team can beat the best solo human and the best solo computer. We are going to see centaur doctors, centaur lawyers, and centaur engineers. The AI will handle the massive data processing and pattern recognition, while the human provides the intuition, the ethical framework, and the final accountability. You wouldn't want a machine to sentence someone to prison, but you would want a judge to have access to the most comprehensive legal analysis possible before they make their decision. Let's look at the infrastructure required to run these post-everything models. We are talking about billions of parameters and megawatts of electricity. The next frontier in AI development isn't just at-speeder code, it's more efficient hardware. We are seeing the rise of neuromorphic computing, chips that are designed to function like biological brains rather than traditional transistors. This would allow an AI with the intelligence of a doctor to run on your smartphone, instead of a massive data center. This edge AI would mean you have a world-class lawyer and physician in your pocket at all times, available instantly and for free. This is the democratization of expertise. The impact on education will be the most immediate change. If an AI can pass these exams, the exams themselves become obsolete. We have spent the last 100 years teaching kids to act like computers, to memorize facts and follow set procedures. Now that we have actual computers that can do that better than any human, the entire goal of education has to shift. We need to teach people how to ask the right questions, how to verify information, and how to synthesize ideas across different domains. A standardized test is essentially a relic of the pre-AI era. There is also the matter of exynthetic data. One of the fears was that AI would run out of human-written text to learn from. But now, AI is starting to generate its own training data. AI Model A can create millions of complex logic puzzles, and Model B can learn from them. This is how AlphaGo became the best Go player in the world. It didn't just study human games, it played against itself millions of times. When AI starts self-educating, the rate of improvement will move from linear to exponential. We won't be talking about the bar exam anymore. We'll be talking about AI solving physics problems we don't even have the math to describe yet. In the realm of software engineering, AI has already passed the most difficult coding interviews at companies like Google. This is leading to agentic workflows. Instead of you writing a piece of code, you tell an AI agent what you want the software to do. The agent then writes the code, tests it, finds its own bugs, fixes them, and deploys the app. You move from being a forewriter of code to being an architect of systems. This shift is happening across every industry that involves a keyboard. But what about creativity and the human soul? People always say AI can't create art or write a moving poem. But if you've seen the latest generative models, they are getting dangerously close. They can replicate the style of any artist and the voice of any author. They can compose a symphony in the style of Beethoven that would fool most listeners. The what's next? Here is the personalized content explosion. Imagine a movie that is generated in real time just for you, featuring your favorite actors, in a genre you love, with a plot that adapts to your emotional reactions. The concept of a Karjid culture might fade as everyone starts living in their own AI-generated reality. Let's talk about the alignment problem. This is the technical challenge of ensuring that an AI's goals stay perfectly aligned with human values. If you give an AI a high-level goal, like cure cancer, and it has the intelligence of thousands of doctors, it might decide that the most efficient way to cure cancer is to change human DNA in a way that has unintended consequences. Or if you tell a CIA-level AI to prevent war, it might decide the best way to do that is to disable every communication network on Earth. As the AI grows more capable of passing these professional gateways, the more dangerous its misunderstanding of a command becomes. The what's next is also about physical embodiment. We are seeing the GPT moment for robotics. Researchers are taking the large language models that pass the bar exam and plugging them into robot bodies. These robots can now understand natural language commands like go to the kitchen and find me something that isn't healthy but tastes good. The robot has to understand what healthy means, what tastes good means, and how to navigate a messy room. By combining A-test passing intelligence with physical sensors, we are creating the general-purpose robot. This is the holy grail of automation. Another massive shift is in personalized medicine. Now that AI has passed the medical boards, it can be used to analyze your specific genome. Instead of a full-size-fits-all pill, a doctor using an AI can prescribe a treatment that is mathematically optimized for your specific biological makeup. This could lead to the end of many chronic conditions as we move from reactive medicine to proactive engineering. The AI doesn't just treat the symptoms, it predicts the failure of the system before it happens. For corporations, the what's next is the autonomous enterprise. We are seeing the first experiments with AI CEOs and boards of directors. If an AI has passed the highest levels of business and legal testing, why wouldn't a company use it to make strategic decisions? An AI can analyze market trends, competitor moves, and global economic shifts with a level of detail no human executive could match. It can run millions of what-if simulations every hour to find the most profitable path forward. This leads to a world where businesses are competing at the speed of algorithms, and the human CEO becomes more of a brand ambassador than a decision maker. Technically, we are also moving toward recursive self-improvement. This is the idea that an AI that is good at coding can write a better version of itself. That better version then writes an even better version. This is the AI intelligence explosion that many futurists have predicted. If the machine that passed the bar exam today can rewrite its own architecture to be 10 times more efficient tomorrow, the gap between human and machine intelligence will become a canyon almost overnight. We are essentially building a ladder into the clouds, and we don't know where the top is. But we have to remember that passing a test is not the same as having wisdom. A machine can understand the law without understanding justice. It can understand medicine without understanding the value of a single life. It can understand intelligence analysis without understanding the weight of history. The what's next must include a deep conversation about artificial wisdom. How do we build systems that don't just optimize for a score, but understand the nuance of human existence? We are also facing a truth crisis. As AI gets better at passing CIA tests and medical boards, it also gets better at creating deepfakes and disinformation. If an AI can write a medical report that looks perfect but contains subtle and dangerous lies, how do we protect ourselves? The very same technology that can cure a disease can be used to create a digital virus that destroys trust in every institution we have. The next decade will be a constant battle between detection AI and creation AI. The what's next is the merger of our lives with this intelligence. We are going to stop thinking of AI as a website we visit and start thinking of it as a constant presence. It will be the exocortex, an external layer of our brain that helps us process the world. When you can consult an AI lawyer, doctor, and analyst in your head via an earbud or a pair of glasses, you aren't really just a human anymore. You are something new. You are a hybrid being with access to the collective knowledge of our species, processed at the speed of light. The AI that passed those exams wasn't the end of a journey. It was the firing of the starting pistol. We have created a mirror that doesn't just reflect our faces, but reflects our intellect. As we move forward, the challenge won't be how to make the AI smarter. That's already happening. The challenge will be how to stay human in a world where the most skilled entities on the planet aren't human at all. We are entering a future that is as exciting as it is uncertain. The exams have been passed. The certificates have been issued. Now the real work begins. We have to decide what kind of world we want to build with this power. Because for the first time in history, we aren't the only ones doing the building. If you are a student, a professional, or just an observer of the world, don't be afraid, but do be prepared. The skills that were valuable yesterday, memorization, basic analysis, and routine processing, are being commoditized. The skills of tomorrow are empathy, high-level strategy, ethics, and the ability to work alongside our new digital peers. The AI has passed our tests. Now it's our turn to pass the test of how we handle this incredible new era of intelligence. The classroom is empty, the exam papers are graded, and the world is waiting to see what we do next. The machine is ready. Are you? Stay curious, stay adaptable, and keep looking toward the horizon, because the change is coming faster than anyone expected. The future isn't something that happens to us. It's something we create, one line of code and one human decision at a time. Let's make it a good one.